Hello, good people out there. This is Quiver from Aaenics Labs, and welcome to another interesting tutorial. Okay, so I know you guys missed my horrible voice. I was actually in a very stressful examination period. That is why the videos were not coming through. But hey, I know if you are already in the Aaenics community, you haven't actually missed anything so great. But then, if you are not in the Aaenics community, I would urge you to hop in and join us at https://aenics.com so that you can access more culturally friendly tech and robotics content, share your ideas and projects, and also meet other, enthusiasts in the African tech community. Okay, Charlie, time no day, so let's go to the whiteboard and see what we have for today. Okay, so today we will be doing one of the awesome things that every maker at some point in time finds very essential to do. That is to display stuff on a screen. As in, you might have a project you are working on where you want the users of your system to be able to visualize some features of the system. Yeah. Some examples are these projects which were worked on by some wonderful makers in the robotics network. So as for an LCD, it's one of the common things that will come to mind. But wait, let me show you a problem. This one is the raw LCD model that usually comes with starter kits. The leads are not even soldered, but then I find it like as an opportunity for even beginners to learn how to solder stuff. The problem here is that if you want to be able to control this LCD with an Arduino microcontroller, you need too many GPIO pins before you can establish the connection. And you see, if you have done something like this before, you realize that it becomes a very big problem when you want to use your pins to control many other components. But then that's where the I2C adapter comes in. I2C on its own is a unique communication protocol used in embedded systems nowadays. In this video, I'm not going to talk about the details of the I2C communication protocol itself. Let's just reserve that one for another video. But then in this video, we are just employing the I2C adapter to simplify the Arduino to LCD process. Yeah. So this is what is going to happen. When the Arduino wants to tell the LCD to do something or to display some characters, the Arduino is going to talk to the I2C adapter, and then the I2C adapter will then talk to the LCD model. Also, because of how the I2C adapter is designed to properly fit behind the LCD, the annoying good news for beginners is that you have to do a few soldering works. And once you are done, you are through with about 70% of the circuitry already. Okay, so as you can see, after you are done with the soldering, all these pins will be taken care of because they'll be connected to each other already. The rest of the circuit that you have to think about is the particular pins that the Arduino connects to. So as for the VCC and then the GND, they are obviously to power the adapter and then the LCD, but then the main wires for the Arduino to be able to communicate with the adapter are these two. Yeah. And please, the SDA stands for serial data and not Seventh-day Adventist. Yeah, so SDA and then the SCL. The SCL also stands for serial clock. You see, these two wires are the only wires necessary to establish an I2C communication between the Arduino and then the adapter. That is how come it is able to reduce the number of pins that you need to program an LCD. Yeah. And maybe you may be wondering why have I even connected the SDA and then the SCL pins to these particular pins. Let me just throw more light on that and let's go. So for every Arduino board you'll be using, there are some particular pins which are designated for some peripheral communications like I2C and then SPI. And some are UART, TX, and then RX communication, those stuff. On an Arduino Uno, these are the two set of pins that support I2C communications. These are the only two set of pins. So it was just my decision to choose those at the top here and not those on the analog rail. Okay, the last thing on the I2C adapter that has to be connected to the Arduino is the backlit or backlight. Yeah, let me say it that way, backlight. Just as the word suggests, it is the pin that controls the brightness of the background light. You can either connect it to any of the pulse width modulation pins on your Arduino, or maybe to a potentiometer, that's if you want to control the brightness manually. Charlie guys, I think at this point the hardware and circuitry shouldn't be any more problem. So let's check out a couple of things from the codes and then upload the magic key. Alright, so apparently the codes are not even as difficult as you would expect it to be. Let me just go ahead and upload this particular sketch, and then I'll come back and then throw more light on a few stuff just in case. Yeah. So as you can see, my test sketch just writes welcome to Aaenics Labs beautifully on the LCD, and that is super simple. You should be able to replicate and customize it. But as I promised, for the sake of a few beginners who may be watching, let me just throw more light on a few things in the code. What is really making the code very simple are these two key libraries which are included at the early stages. So you include the wire.h library and then the liquid crystal I2C library. The link to all these two libraries are in the description in this YouTube video, like below this YouTube video, so you can just click it and download it. The wire.h is the one handling all the I2C protocol communication, and then the liquid crystal is like linking the I2C to the LCD library in particular. Yeah. The next important thing is this particular line here at line 4. So here at line 4, you're actually creating an object for your particular LCD you are working with. Yes, so you are going to describe your LCD and you're going to give it a name so that the computer knows where to find that particular LCD. That is why you create this object. So 0 times 27 is a hexadecimal number. When you convert it to normal decimal, it's like saying 39, but the computer says 0 times 27. It's the name that the computer has given to your LCD. And then 16 then times 2 is just the number of columns and the number of rows you have on your LCD. If yours is 20 by 4 or 100 by 200, you can just write it there. In case you're asking me how did I get the 0 times 27, okay, so let me show you something important. When you're working with any I2C device, every device will have its own address or name. Just like maybe when your mom gives birth to you, calls you Kofi or Kweku. So every I2C device has its own name. You may not know their name, so what you will do is to run a simple sketch. Let me show you where the sketch is. It's called an I2C scanner. So you can just go to your examples and look for the wire library. Yes, and that's it, I2C. Okay, have I opened it? Yes, this is I2C. So this is the I2C sketch, I2C scanner sketch. When you run this sketch, it's going to check your whole circuit and look for all the I2C devices that you have in your circuit, and then it will give you the respective names for them. So let me run it and you see what will happen. Let me open the serial monitor too. Okay, I'm ready. Show me. Aha, so that's it. So you see, I have just one I2C device actually connected right now. That is why it's saying that an I2C device has been found at this particular address. That is why I have 0 times 27 there. So just take note of that. Let me continue with the actual codes for the day. Alright, so as for the rest of the codes, it's just something for the beginner. And yes, pin mode, we are just declaring. Okay, sorry. So pin mode, pin 9
pin 9 is the pin that I'm using to control the brightness of my LCD. If you remember, I showed you one backlight wire that I connected to any of the pulse width modulation pins, and on an Arduino, yes, pin 9 is a pulse width modulation something pin. That is why I connected it there. Yes, so lcd.init. The rest are just functions that are found inside the LCD library itself. So lcd.init is what initializes the LCD. And you see, I'm doing all this inside the setup. There's nothing in the void loop. Everything is inside the setup, because actually writing welcome to Aaenics Labs is not something that you want it to happen like repeatedly over and over and over. It's just something simple. I just want to say, hey, welcome to. Okay, I said welcome to the Aaenics community. Okay, I changed it later. Okay, so the other function you should pay attention to is the set cursor, which is used to align your text on the screen. No, this should be 3. No, that should be 1, and then this will be 3, and then this should be 2, and this should be 1. Yeah, these are all just alignment stuff. I'm just using it to align my words on the screen. I want them to be in the center. That is why I'm doing all this. Good. And to print anything, yes, lcd.print. That's all. The last one is the analog write 900. So 9 is the pin that I've connected my backlit wire to, and then 100 is the amount of light that I want to be present on my screen. This number actually ranges from 0 to 255. Yes, it's an analog write something, so it ranges from 0 up to 255. So that's it for today. Hey, don't forget please to like this video and then subscribe, especially those who maybe this is the first time you're watching me. Please subscribe to this channel. Alright, God bless you and have a very nice day.